Let's get ready to do some math. Another AP Calculus instructional video. Happy Monday. I think today is Monday. Okay. You had an assignment due Friday by midnight. You got another assignment due tonight by midnight. Okay. I want to make sure you guys are actually putting in work. Let's do differential equations, slope fields, day two. Okay, and we'll actually start to move into some other types of topics today. We're getting close to the end of that part 2 review. Hope you're putting in work. Star! So it's really differential equations day 2. I'm not going to write that. I just wanted to say star. Every now and then, implicit differentiation becomes involved in differential equation problems. You can see 2004, number 4. Consider the curve given by this thing right here. Okay, I considered it. Show that dy over dx is equal to 3y minus 2x over 8y minus 3x. Taking the derivative, finding dy over dx. Implicit differentiation. If you want to find the derivative with respect to x and there are other variables present, it's an implicit differentiation situation. Or if you see x's and y's frolicking about together, implicit differentiation situation. You can see, by the way, you end up with a differential equation, and that's why sometimes you see these problems that are related. Some weird stuff going on in this problem. Will you have one like this? Well, your AP, who the heck knows? I'd say probably not one exactly like it, but you never know, but even the other years when you got 6 AP problems, who knows if something like this would show up. Some problems show up all the time. Some problems show up every now and then. This is more of an every now and then. Easy for part A right here, okay, which is worth, 2 points? This is like a gimme right here. The derivative of the left-hand side can split it up over addition. So the derivative of x squared with respect to x is 2x, or 2x dx over dx. You don't need to write it. But the derivative of 4y squared is going to be 8y. You better put a dy over dx next to it to indicate respect to x. X, I'm going to give you respect on this. Today, your daughter's wedding. Remember, what's really happening is you're multiplying by the derivative of the inside, and the derivative of y with respect to x, dy over dx. The derivative of 7 is 0 plus, excuse me. Oh, 3xy. Product rule makes me drool. How does product rule start? Back on. All right, so we know the second function is y times the derivative of the first with respect to x. So the derivative of 3x with respect to x is 3, plus the first, which is 3x, times the derivative of the second, and the derivative of y with respect to x, dy over dx. Very, very doable. Remember, 99% of the time, you want to move the dy over dx to the left-hand side like they have, because you might end up with 2x minus 3y over 3x minus 8y, which is equivalent to this, but you might not know that it's equivalent, okay? So I'm going to actually subtract the 2x from both sides. There's a plus 3y over here already. I'm going to leave the 8y dy over dx. And then I'm going to subtract 3x dy over dx on both sides. And look, you can skip this step. I mean, a lot of people go right to factoring out the dy over dx and getting 8y minus 3x. I'll say it's equal to, if you don't mind, 3y minus 2x. And now if you divide by izzy booble, you get the dy over dx is 3y minus 2x over 8y minus 3x. And that's what they had. Okay, so thus it is shown. We've done part A. Was it a part A? Anyway, part B. This one's a little weird. Show that there is a point P with coordinate x coordinate 3 at which the line tangent to the curve at P is horizontal. Find the y coordinate of P. So they want you to show there's a point P with an x coordinate of 3 at which the line tangent to the curve is horizontal. Remember, if you have a horizontal tangent line, that means that you have a slope equal to 0, which means dy over dx is equal to 0. And they want to know what the y coordinate of P is. Well, look, they're telling you that at this point P, the slope of the line tangent is 0, right? The tangent line's horizontal. So that means that dy over dx has to equal 0, like I wrote a moment ago. And we know what dy over dx is. Okay, dy over dx, 3y minus 2x over is equal to d, 8y minus 3x. We know that's equal to 0. Now you could actually cross multiply. 3y minus 2x times 1 is 3y minus 2x equal to 0, right? People are like, how am I supposed to solve for y? Well, they tell you the x coordinate is 3. Okay, so if I replace x with 3, and this is kind of playing around. People are like, well, how would you know to do this? How would you, to see a problem like this? Who knows? This is weird. You don't always see problems like this, but play around. You could do things like this. We know that y has to equal what? 2 here. All right, so that means that the point we're talking about is the point 3, 2. You know, the problem is they want you to find that y coordinate. We got y is equal to 2, but a lot of people leave this out, and this is worth 3 points. So you probably got 2 points right here, so don't freak out. But it said show there's a point P with x coordinate 3. You got to show that this point actually lies on the original function. Okay, so what you have to do is actually plug this back into the original x squared plus 4y squared equal to 7 plus 3xy. Make sure it's actually a point on the function, okay, or on the curve in this case, because technically it's not a function. So here we got 2 squared, not 2 squared, x is 3. Pardon me, pardon. Trying to get the British accent going. My daughter loves watching the Paddington Bear movie. There's a girl in there talks into a British accent. She's like, I know everything about bears. And that's like what my daughter walks around saying. She's like, Daddy, I know everything about bears. It's very cute, but Ava, not quite as good as you, but she's young. She's learning. 3 squared plus 4 times y is 2, right? 2 squared. Does it equal 7 plus 3 times x was equal to what? 3, and y was equal to 2. And it does, okay? This is 9 plus, 16, so 25 equal to 18 plus 7, which is also 25, so it works out. A lot of people wouldn't realize to do that, and I get it, okay? I wouldn't worry so much about that. I worry more about this, something you could all do. Part C is where the froth really begins. It's not the first part, though. You know, find the value of d squared y over dx squared at the point P found in part B. That should actually be easy. Then they want to know if the curve is a local max or a local min or neither at P. That's something that we spoke about earlier in this year. It's been a long time, so we'll talk about that again. But the first part here, which you probably get at least 2 points for. So you can think 2 points right here, another 2 points right here, and another 2 here. That's 6 out of 9, which is pretty good. You know, if you actually want to, what the heck do they want? Find d squared y over dx squared. Well, we got to take the derivative. So once again, implicitly differentiate. I'll just rewrite the original so we got it for reference, for ref. Okay, and when you differentiate both sides, the derivative of dy over dx with respect to x is d squared y, excuse me, over dx squared. Definitely drooling this time, because this is a quotient rule situation. Back in! We got 8y minus 3x times the derivative of the burst, okay? And the derivative of 3y minus 2x is going to be 3 dy over dx minus 2. So definitely a lot more crunchy than some other problems we did. Minus the first function, burst, times my personal favorite, derivative of the back end, and the derivative of 8y with respect to x is 8 dy over dx, minus the derivative of 3x with respect to x, which is 3, and don't forget we're over Beckon squared. So this is definitely a little bit annoying, taking that derivative, then evaluating it at the point in part B. Here's one of those things, if you couldn't figure out the point in part B, doesn't mean you can't just make up a point and evaluate the second derivative of that made up point. Don't use like 0, 0, something like that, because it makes it too easy. Also makes it undefined in this case. But you're supposed to pick an answer that's the same difficulty as what the true answer is, which is impossible, right? Because you don't know what the true answer is. That's why you're picking an answer. But do the best you can. Try to pick, even something like this would be pretty good. 3, 2 or 2, 3, something like that. But anyway, when we plug in, really annoying here without a calculator. So 8 times y is going to be 8 times 3 is 24 minus 6. Okay, so what is that? 18 right there. Okay, that 24 minus 6. Is it 18? Am I crazy? 8 times y. 8 times y. Sorry, 8 times y. So that's 8 times 2, which is 16, minus 3 times 3, which is 9. So 16 minus 9 gives us, what, 7 there? My apologies. 3 times dy over dx minus 2 bothers some people because they're like, what the heck is dy over dx, you know? Well, at the point 3, 2, you can get what dy over dx is equal to by plugging 3, 2 into the original, but I wouldn't waste so much time with it. We know it's 0. That was the whole point of doing this right here, right? But just don't forget the 0 afterwards, you can subtract 2. Okay, minus 3y minus 2x. Okay, if you actually plug in there, 3y is 3 times 2, which is 6, minus 2 times x, which is 2 times 3, which is 6. You get 0, which means I don't give a good gosh darn what you get here. You get a negative 3, but it doesn't matter because you're going to multiply it by 0. Anyway, it's going to get wiped out. And down here, we already did this guy. We got 7, so 7 squared down here. So we actually end up with what? Negative 14 49ths. Technically, you could leave it this way. You would not be incorrect, okay? It's the same exact thing. Why is this useful right here? Well, the second part of the problem, now they want to know if the curve has a local max, a local min, or neither at point P. And it's weird because you're like, local min, local max. I mean, surely there must be some sort of test, but it ain't the second derivative test. Well, believe it or not, there is a second derivative test for max and min. Okay, we're going to say this. We're going to say at 3, 2, it involves the first derivative. So we know that dy over dx equals 0. Which actually means the function is going to have a horizontal tangent line at that point 3, 2. And now we know the second derivative, d squared y over dx squared. We know it's negative 14 over 49. So we know it's negative. And since it's negative, that means the function is honk down, right? And if you're concave down, if you look like an N at a horizontal tangent line, guess what you have? You have a maximum, okay? So local max. And the justification is really because what we have written, because the first derivative is equal to 0 and the second derivative is negative. You know, if you're freaking out about this, if the second derivative is positive and the first derivative is equal to 0, then you got a little smiley at a horizontal tangent line. That means it's a local min. And if the second derivative to get the neither was actually equal to 0, that means it's an inflection point. It's either going to be the increase in the increasing guy or the decrease in the decreasing guy. Second derivative test for max and min. We did it earlier in the year. We really did. Okay, it was on a test and everything. You don't see it all that often. Will it be on your AP? It's probably doubtful. But then again, you never know, which is why we do stuff like this, and it's really not too difficult. It's how you get a max or a min with the second derivative, but it's kind of silly to say the second derivative test because the first derivative is involved as well. So a weird problem, not that it's a terrible problem, it's a little weird. Not the easiest 9 out of 9 there, but you could get pretty close. Let's move into 2003. Okay, my first year teaching, this is the AP exam. I wasn't teaching AP yet. That was Mr. Matina here. And we got a coffee pot. You know how much I love coffee. I love coffee. My own. My precious. Anyway, so a coffee pot has the shape of a cylinder with radius 5 inches. Who thinks about these things when they're making coffee in the morning? I'm half asleep, as shown in the figure above. Let H be the depth of the coffee in the pots, not the depth of the cylinder, the actual coffee that's in there. Liquid takes on the shape of its container, so it's going to be a cylinder inside there. Measured in inches. H is a function of time, measured in seconds. So at any given instant, any given second, you could plug into H, figure out what the height of this coffee is, the coffee in the pot. The volume of coffee in the pot, they tell you, is changing at this negative rate of change right here, which should make sense because as you drink more and more coffee, you can see that the amount's going to be decreasing, so the volume should have a negative rate of change. They even give you the formula for the volume of a cylinder. We actually had part A for this on a test earlier in the year on related rates. Because this is a related rate situation. The volume of the coffee in the pot is changing at this rate. The rate at which volume is changing with respect to time, that's dV over dt equal to negative 5 pi radical h. And now they want dH over dt, okay? Well, the only formula they gave you was volume equal to pi r squared h. And to get dH over dt, you need to take the derivative. Now, there's two things you could do here. Excuse me. You could take the derivative on the right-hand side using product rule, but you need to be careful because when you use product rule, you know, and don't just take the derivative both sides and multiply, okay? You want to actually expand the product rule. A dH over dt is going to show up, which is great because we need that, but a dr over dt is also going to show up. And people are like, well, what the heck is dr over dt? Well, that's the rate at which this radius is changing with respect to time. And you could call it r if you want, but that's silly because we know it's actually equal to 5, okay? And if something is constant, that means its rate of change is equal to 0. So you could do it that way and say, with product rule, say dr over dt is equal to 0, but you don't need to do that. Remember, related rate, the diagram has to work for any time t, which is why h is variable and r is not variable because r is constant. And the formula you choose to back it up also has to be, you know, working at any time t. It's going to be variable, but if something's constant, you can replace it in the formula. Like I know the r is always 5, so I could say volume equals 25 pi h, okay? And it's a much easier way to do the problem, or you can go product rule and use the fact that dr over dt is equal to 0. But now when I differentiate both sides, dv over dt, div over dit, is equal to what? 25 pi. The h goes away, but we need that dh over dt. Okay, and we know dv over dt, negative 5 pi, what was it, rad h, equals no values to replace here, right? 25 pi is a constant. And all we want to show is that dH over dt is equal to this puppy right here. So divide by 25 pi on both sides. Okay, and then we get some nice canceling going on. Divide by 5 top and bottom. Divide by pi top and bottom. And we actually end up with what? Negative radical h over 5 equals dH over dt. And man, that's convenient, okay, because that's exactly what they wanted us to show. So a cool little related rate put in there. Related rates used to be big part 2 problems. Now they're only pieces of part 2 problems. Gosh, could they turn into a big part 2 for your AP? I don't know. I really don't think so. Okay, the reason people struggle in related rates is a lot of algebraic stuff to set up. Here they kind of gave you everything, but in those big part 2 problems of the past, and there hasn't been one like that since pre-2000, it's been over 20 years, you know, you really need to work on algebra and stuff like that. So I wouldn't worry about it. B, you know, why is a related rate problem in the differential equation, packet, Mr. Berto? Well, I'm glad you asked that, because given that height equals 17 and t equals 0, condition. Solve the differential equation. Whoop, there it is. Whoop, there it is. Come on now. Whoop, there it was. For h is a function of t. So it just means when you want to solve dH over dt, treat the h like it's a y, treat the t like it's an x. I'll leave the negative up top here. You're going to want to put it with the top or the bottom. I'm not going to put it on the bottom because when I cross multiply, remember, I want to keep the left-hand side as clean as possible. There's already a 5 over here I'm going to have to get rid of. I don't also want a negative over there. Then again, if you do put the negative there, it's no big deal. Because right now I'm going to divide by 5 on both sides. You could easily just divide by negative 5 on both sides. We're separated, not yet, right? You know, this radical h, he should be over here with the dh. So that radical h, I'll divide by radical h on both sides, which is really multiplying by 1 over radical h. And then I'll multiply by 1/5 on both sides to get rid of that 5. So the negative's still here. Now I'm bringing a 1/5 over there. So the algebra is not really too terrible. And don't integrate right now. People are like, yeah, integrate a quotient, you know, we're just going to say ln absolute value radical h. No, that's if you integrate a quotient and the bottom's not raised to a power. Here it is being raised to a power. In fact, you want to write this as h to the negative 1/2. That's what puts it in a pleasurable form to actually integrate, right? So integrate, ain't it great? H to the, add 1 to the exponent, negative 1/2 plus 1 is positive 1/2. Only Sabrina or Ryan Booty would divide by 1/2. The rest of us multiply by 2 over 1. Integrate negative 1/5 with respect to t, negative 1/5 t plus c. And once again, you could use this as your general solution, but I always clean up the left-hand side of constant, so I actually multiply by 1/2 on both sides. Okay, and here we're going to get h to the 1/2, so how about radical h, just for kicks and giggles, is equal to what? Negative 1/10 t, and then just plus c, right? A constant times a constant, just another constant. Okay, so hopefully that's not too terrible right there. But they gave us an initial condition. T is 17, h is 17, pardon me, when t is equal to 0. I love the initial conditions when one of the variables is equal to 0. Makes it so much easier to solve. So now I know that I got radical h equal to negative 1/10 t plus radical 17. And remember, I don't use an advanced algebraic technique until I solve for c. Now I can use an advanced algebraic technique. How do you turn a radical h into an h? Square both sides. People are like, oh, do you got to worry about the positive square and the negative square? There is no positive square and negative square. We're not taking a square root. We're squaring, y'all. You actually get h is equal to, I'll leave it as negative 1/10 t plus radical 17 quantity squared. Okay, intense problems right here. You might be like, wow, it seems more intense than the stuff we did earlier in the year. That's the deal with the AP exam, okay? Remember, 68% will net you a 5, okay? So stuff's supposed to be tricky. This is really not too terrible, and this is worth 5 points right here. Part A was worth 3 points. You could be at 8 out of 9 right now. That's huge. So C is only worth 1 point. At what time T is the coffee pot empty? A lot of people say that's when the volume is equal to 0. It won't really help you here because we don't have that formula for volume, but we do have a formula for height. You know, the coffee pot is empty when this height is actually equal to 0, right? Because then you've drank all the coffee. So coffee pot, does coffee have 2 E's? Coffee pot empty, ... when h equals 0, and they want to know the t value at which that occurs, where you could just replace h with 0 right here. 0 is equal to negative 1/10 t plus rad 17 quantity squared. And now you could pretty easily solve for t. Okay, I'd start by taking the square root of both sides. Okay, square root of 0 is 0. And you can think about positive square root, negative square root, but we don't want to end up with a negative value here because t represents time, so you can write to the positive square root. All right, subtract radical 17 from both sides. Divide by negative 1 on both sides. Then divide by 1/10 on both sides, or multiply by 10 on both sides. So 10 radical 17 equals t. Units! I need units. Okay, I think t is in terms of seconds. So make sure you got your seconds down there. So something cute, they don't always ask about. These problems have kind of gone out of vogue, but they might be coming back with the whole Common Core thing, especially on your AP2. They want to give you some kind of part 2 questions that you won't really be able to just Google the answers for. I don't know what that even means, okay? But I'm telling you right now, I really feel like a differential equation is going to be a big part of it, because differential equations always show up as one of the part 2 problems. And that's the last topic up to the stuff you're supposed to cover on the AP exam, because they cut a topic off. I'm telling you, my spidey senses are tingling, okay? I really think you're going to see a differential equation type of problem. So I hope you are trying these problems. Got an assignment due by midnight tonight. Make sure you're doing those assignments, okay? Some people are like, well, I'm in college already. What do I care? Blah, blah, blah. What do I care? Fine, you can be that way. But really, all the work you put in from last year to this year, just the fact that you've suffered in my classroom listening to my voice, I mean, why would you not want to go ham, all right? You know, rock and roll this thing, okay? And then after May 12th, you could just sit back and then just relax, okay? So I hope you're looking at this stuff. Everybody stays safe and healthy. Mr. Berto signing off. See you later, y'all.